There we go. All right, so let's start the z times w. Let's see what we get here. Here's my messy z. Actually, you know what? I'm going to kind of skip that step. I'm not going to write it. Honestly, I think you guys are good with that. I'm going to go straight to this formula where I have the z times w means R1 times R2. My R1 and R2 are like the radius from both of those, the z and the w. I need to multiply them together, so I'm going to do like a 3 times 2. All right, and then in the bracket here, I've got cosine of my two angles added. Let's see, my theta 1 and theta 2. There we go. Let's add them up. So a pi fourths plus a 3 pi fourths. They have common denominators and everything. That's nice. Plus I sine of same thing, pi fourths plus 3 pi fourths. All right. At this point, I got to simplify. So I'm going to get my 6 out in front here. Cosine of, let's see, 1 pi fourths plus 3 pi fourths, so 4 pi fourths, just a pi. We go with that? 1 pi. It's the same angle on my sine and cosine. If you got a different angle on those, you know something's a little off. All right, and then on my unit circle, I should be able to get the cosine of pi and the sine of pi. So let's see here. Abdi, what's the cosine of pi? Yeah. And then Devin, I'll come to you for the sine of pi, okay? Sine of pi. So cosine of pi is a -1. That's true. Nice pretty whole number. We should be able to get this off our unit circle. Your sine of pi. Do you remember what the sine of pi is? Ooh, so that was cosine. That was like my x value at pi. 0. Okay, so the y value. Nice. The y value is your sine, so a 0 times I, which that's out. This is going to end up with a 6 times -1, so just a -6 here. Here's my z times w, a -6. Nice color. All right. So that was, yeah, z times w. Let's do the z over w. In fact, I think you guys can set it up. Will you guys do the z over w? And I'll see if we got it right. All right, so I'm just going to start calling on people as we go through here. So Eric, I'm going to come to you first for the first part here, my R1 over R2. So Eric, what'd you get for that?
3 over 2.
3 over 2, got it. 3 halves there. Okay. And then, let's see, let's look at the angles here. So Trissy, I'll come to you for the angles. So Trissy, I was taking cosine of what angle?
So wouldn't it be negative 2 pi fourths?
Oh, negative 2 pi 4. So this was
If you simplify it.
Yeah. So negative 2 pi 4ths, which I think we can even simplify that a little further, right? So that would go down to like what, negative pi halves? I simplified all the way down. Which my cosine and sine should have the same angle. So we should have got I sine of a negative pi halves as well. Did everybody get the same angle here? Yes, nice. Okay, which we had to find negative pi halves on the unit circle. All right, so let's leave the 3 halves for a sec here. All right, so Maddie, what's my cosine of negative pi halves? Yeah, it's 0. Your negative pi halves was like down here, the x value, your cosine is 0. Nice. All right, and then let's see, for my sine of negative pi halves. So let's go to Zach. I think you're at home. Zach, what's the sine of negative pi halves?
One.
Close, close. See where this is
Negative 1.
There you go. Nice. -1. Sine of the y values. That was a y value of -1. Okay, which I don't really need to worry about adding this 0 here. I'm just going to multiply my 3 halves times my -1. So I'm going to get a -3 halves times I. All right. Do I have any questions on these? Girls, we're good? You guys can do some homework? Okay. All right, let's go to this guy then. Very similar. It's just not as pretty. Here's what I mean. My z times w, I'm going to use the same formula. I'm going to multiply the 3 times the 8. Okay, so I've got my 24 here. And then I've got the cosine of my angles added. So let's see, my angles were a 300 and a 75. So I've got cosine of 375 degrees. Cosine and sine should have the same angle. So plus I sine of 375 degrees. Okay. But isn't 375, first of all, it's past 360, right? And I don't think that's one we memorized. It's 15 degrees past 360. And we didn't memorize 15 degrees on our unit circle. So we're probably gonna have to bust out the calculators for this one. All right, so I need to do my, like I said, my cosine, 375, okay. All right, is this what you guys got also, this 0.965, yada, yada? All right, I'm gonna leave this thing in my calculator. The sine of 375, there we go. Or honestly, if you put sine of 15 degrees, you get the same thing. All right, so here's my 0.25, yada, yada. All of that, I have to distribute my 24 and then we'll call it good. When I distribute my 24, I saved that whole thing in my calculator, so I can do 24 times that entire decimal. All right, so 23.18. We go to 2 decimals. Plus, all right, and then 24 times this other decimal I got from the sine. Got that whole shebang there. All right, so I'll go like 6.21. And the I is still connected to that. All right. There we go. Do I have any questions on this one? Even if it's messy? No. All right, well then let's have you guys, you're gonna have to use your calculators. Bust out those calculators. Let's have you guys do the Z over W again. Just don't round to the very end. All right, hopefully we're getting there. Shara, will you let me know what this number was that you put in front? Z over W. What was the constant you put in front?
I'm still trying to figure it out.
Okay, so let's look up the formula here real quick. For the division ones, I do R1 over R2. It's like the stuff that I circled, those are my R1 and my R2. What do I get for my fraction here?
3/8.
3/8, nice. All right, and then I need my angle. It's not straight up 300 or 75. We got to use them together. Fiona, what did you get for the angle? We got to use the same angle on both of these. What is it? Let's see, Fiona, did you get that angle?
The angle of 75.
I got to use the 75. I do have to use the 75. I think so. I'm looking at my formula here. So what I circled was my angle had to be a θ1 minus θ2. I got to use both of these angles together. I use the 300 and the 75. So what's my θ1 minus θ2?
It would be 225 degrees.
There we go. Yeah, 225.
That's negative 0.707.
Oh, so you already put it into your calculator?
Yeah.
Okay, cool. Sorry, this is not, go away. Sorry. Come on. Oh, this thing popped up. Give me a sec here. Okay. All right, so we were saying we had to subtract them for a 225. Is that what I heard? On both those guys? Which is not something we memorized. All right, so let's see here. In the calculators, let's do the cosine of 225. And let's do two things at once. I'm going to multiply my 3/8 times the cosine of 225. Okay, so if we multiply those together, let's see here. Ethan, what'd you get for those guys multiplied together?
Cosine
Of the 225, yeah, and then multiplied by the 3/8.
negative 3 square root 2 over 8. Probably did that wrong, but
Oh, so were you going off of like a definite place on your unit circle?
yeah.
All right, so where's the 225 on your unit circle?
It's like in the left quadrant.
Okay. Is it one that you had memorized?
Yeah.
All right.
Negative square root 2 over 2.
This one right here?
Yeah.
Let's see. So it's like 45 degrees past my 180. So this guy right here was you said negative root 2 over 2 and another negative root 2 over 2. But the sine and the cosine were the same. All right, so yeah, negative root 2 over 2 times 3/8 gave us a, what about the 8s here? Because wasn't it doing, yeah, negative 3/8 times my, and you said negative root 2 over 2, right? So I'd get a 3 root 2 over 16 then? Is that better?
Yeah, it's like the same one for the 3/8 is a negative. I don't know. I just
Oops,
put my
sorry.
calculator in and simplified the negative 3 for 2 over 8. So.
Negative 3 square root 2 over 8. So I guess I'm curious, if I was multiplying straight across here, I'd get a negative.
Oh, I put it in wrong. That was probably one.
Oh, you're good. Okay, so we have a 16 in the denominator. Are we okay with this? 16 in the denominator, okay. So then I get, my sine and cosine were the same, so I'm still gonna have just like a negative 3 root 2 over 16 again times my I. Okay, so we did have something actually on our unit circle that we had to have memorized. So yeah, we actually got an exact value here. It wasn't rounded or anything. It's kind of nice. Okay, questions on this?
Oh yeah, can we also just like on the test, can we just write that in like decimals?
No, not the ones that are on your unit circle. If it's something on your unit circle, you should give the exact value. The ones that are not something you memorized on the unit circle, then go ahead and do the decimals around those. But if it's hitting a point that you memorized, we need the exact answer. Okay. So that was the difference between part A and part B, why I rounded part A 375 or 15 after 360 was not something I had memorized. Okay. So let's see here. We've done a couple of these multiplying and dividing ones. Any other questions on the multiplying and dividing stuff? Everyone? We're all right. Okay, De Moivre's theorem. Have you guys heard of De Moivre's theorem before? All right. So De Moivre's theorem, you can see what the equation is. This is when you are taking it and raising it to some exponent. Like they've got this messy complex number raised to an 8th power or raised to the 6th or whatever. So we're gonna use De Moivre's theorem for this. I mean, you could if you want. Do you guys really want to list like 8 of these guys and like distribute?
No.
Yeah, I figured we didn't want to. Okay, so we're gonna use De Moivre's theorem for that. So this is gonna give us your r to the n cosine of n theta plus I sine of n theta. My n is the exponent. So in this case, n equals 8. All right, let's see here. This, if I find my theta, I'm actually going to do this kind of like we did at the beginning here. Theta is the tangent inverse of my b over a or my y over x, same thing. In this case, it's like a 1i, so like a 1 over negative root 3. Which hopefully, you guys are used to seeing everything over 2 on your unit circle, right? Root 2 over 2, root 3 over 2, 1/2, they're like all over 2s. My point is, I would kind of treat this like it was tangent inverse of like 1/2 over a negative root 3 over 2, because it would simplify down to my negative 1 over root 3. But I think these are stuff that we can memorize off of our unit circle. Hopefully this kind of triggers where it is. Again, I'm treating it like the y over the x. So where on my unit circle is the y a 1/2, a positive 1/2, and my x a negative root 3 over 2? Which angle is that at? 150. Okay, so like 30 degrees short, like right here. Negative root 3 over 2 for my x, a positive 1/2 for my y. Okay, so that's the angle we're looking at. 150 degrees. Okay, So I needed this theta. I needed to put that into this equation. So I've got the theta, I've got the n. I think we still need to find the r, right? It's got a theta, an n, and an r in this equation. Okay, my r. Let's do kind of what we were doing at the beginning again. I'm going to do my negative root 3 squared plus my 1 squared. So this is like a 3 plus 1, so square root of 4. Should I have a negative?
No.
Or usually on my, when I do square roots, don't we always put like a plus or minus, like a positive or a negative?
No.
No, with the radius, I'm going to go with just the positive, so positive 2 here. All right, so that means I've got the r, I've got the theta, I've got the n. Okay, so I've got pretty much everything I need for this equation here. I'm going to do my r, which we found was a 2, raised to the n, which is 8. Okay, oops, not equals, times cosine of n times theta. My n again is an 8 times my theta was 150 degrees, right? And I will have the same angle for my sine and my cosine. Okay, let's see, what is 8 times 150? I bet it's more than 360, that's for sure. It's 1200, okay. So let's see. If I've got, so 8 times 150 equals 1200. Let's figure out where that would hit on my unit circle. Like the coterminal angle. Like subtract 360, subtract 360 as long as you can to get within 0 to 360. Does that make any sense? How many times do you have to subtract 360 on this guy? 3 times. 1200 minus, so you did your 360 times 3, did 3 of those 360s? What do you have left over then?
1.
Oh. Nice, Trissy. Yeah, you subtract it all off. We have 120 degrees left, which is within my 0 to 360. It's like 1 rotation on my unit circle. So yeah, I'm going to treat these like cosine of 120 degrees and I sine of 120 degrees. All right. There we go. 2 to the 8th. Did anybody actually put that in the calculator? 2 to the 8th?
256.
Nice. 256. I am not putting this cosine of 120 in my calculator. I should have that memorized. Let's see. 120. That's like 30 degrees. Oops. Not a very pretty picture, but that's good. Like 30 degrees past my 90. Which its point, let's see here. Callie, what's the point for this 120 degrees?
Negative 1/2 comma square root of 3 over 2.
Nice. Negative 1/2 for my x, positive root 3 over 2 for my y. So that pretty much, the x is my cosine, the y is my sine. This is going to give me my negative 1/2 for the cosine and my root 3 over 2 for the sine. Okay. And I still have the 256 out front of this. Let's see, if I distribute, let's see, 256 divided by 2 is what, 128? And it's a negative 128 here. Plus, then I'll have a 128 root 3 times my I. Okay. There we go. We did write our answer in complex form. There are 2 different forms that we had to be familiar with. Trigonometric form or complex form. We got the complex form. All right, so refresher. There were 3 things I had to find. I had to find my n, I had to find my theta, and my r. Okay, I found those first. So any questions before I have you guys try it on your own? All right, let's have you guys do the next one. See if you can do it on your own. Find those same three pieces first and then use them in the formula. All right, we getting there, ladies and gents? All right, so whenever you're ready, I'm gonna have Brett's. Are you there?
Yeah.
Okay, nice. So Brett's, whenever you're ready, I'll have you give me the N, and then Erica, if you're there, I'll have you give me the theta. So Brett's got the N, Erica's got the theta. Ian, I'll have you do the R. Okay, those are the three things I need. So just whenever you get them, let me know what you got.
The N6.
Alrighty. N equals 6, okay. Looking good. And then I need the R and the theta. Whatever order, I don't really care. Okay, you're good, Erica. So Erica, it's kind of this stuff right here. This is what I would do for my theta, that tangent inverse. Just in case you knew that. And then, yeah, Ian, whenever you're ready, let me know what the R is. Okay, so Ian, I think I would use this guy right here for the R. Is our equation kind of like Pythagorean theorem, essentially? So just a refresher, how I found this one was I used my -√3 from the stuff in the parentheses. It's like my A, my +1 also came from the parentheses, it was like my B. So Ian, let's see if you can do that with these guys. It will be under square root. That is true. Oh, true. Okay, so what is I squared actually? Okay, let me clarify. Notice that I don't have any i's in my r. Do you notice this? I don't have any i's in that equation that I did for the r. I took the coefficients. So like I just used the -3 and then just the 1. I didn't use a 1i. I used just the 1 in this equation. Does that help at all? There you go. And that's under square root still, right? Okay. So yes, my r is, you said square root of 2. But again, how I did this was I had a 1 and this is like a 1i. So I was using a 1 and a 1. That's how you got your 2, right? 1 squared plus 1 squared is 2. So I got square root of 2. All right, so we've got the n, we've got the r, we need our theta. All right. So we were doing that based off of this tangent inverse right here. So Erica, whenever you're ready for that, let me know what your theta is. All right, so while Erica's working on the theta, I'm going to start plugging these guys into my equation. So I was going to get my r, so root 2, raised to the n, so raised to the 6th, times, and then I needed cosine of the n times theta. My n still is 6. So 6 times whatever my theta is, plus I sine of 6 times whatever the theta is. Oh, you're close, Erica. It's in the 200s. Yep. I think we're off by a little bit. Oh, actually, it's not in the 200s. My theta off of, oh, go off of your first quadrant there. So I think, were you getting that out of your calculator, Erica? That's probably what the calculator gave you. Okay, so let's see here. I'm looking for theta on my unit circle. I need my tangent. I'm doing tangent inverse of, let's see here, 1/1, really. Like the stuff I had in yellow, they're both 1s. So tangent inverse of 1, the only place where I can get like a positive 1 for my tangent is either in the first quadrant or the third quadrant. And you were doing the 225, which is down here in the third quadrant. I need my first guy though. I need the first quadrant, this right here. So Erica, how many degrees is this in my first quadrant for my tangent to be a 1? Totally, nice, 45 degrees. Okay, so I've got to do 6 times 45 degrees. We had to find those first 3. Any questions on these first 3 key pieces we need to find? Your n, your r, your theta. Any questions on these guys? Girls? All right, at this point, it's kind of nice on this one. My 6 times 45, it doesn't go over a full circle. That's a 270, right? So I didn't have to do the whole, making it into, a 0 to 360 section. It already is. So cosine of 270 degrees plus I times sine of 270 degrees, which I think we know where that is on the unit circle. What about root 2 raised to the 6th?
8.
Yeah, it's a nice, pretty whole number, right? It's basically like 2 cubed. So it's an 8. Yes, looking good. All right, this other one, 270 is right down here. Here's 270 degrees. Nicole, 5 pi fourths is over here. It does give you a 1, but we are trying to do like the first one that we would hit, rotating counterclockwise, the first one we would hit is at 45 degrees. So that's why I'm gonna go with that one. Yep. All right, so my 270 is the point, let's see, 0, -1. 0 is my x value, so cosine here, cosine 270, that's 0. Sine of 270 though, that is a -1. So I've got 8 times -1, so -8 I. Here, I'll break this down for you. 8 and then 0 plus I times -1. But yeah, I got a -8 I. Alrighty, so this is pretty much what you're gonna have to do on your homework. Any questions? No? All right.
Oh, sorry. Are we going to get any like equation sheet for the test?
Yes, I will make an equation sheet for the test again. Yep. All right, so don't stress about memorizing. You do have to know how to use it though. So that is what we're gonna practice on the homework. You guys have your WebAssign homework today, and then there will be posted tomorrow. There will be a review posted on WebAssign, okay? So make sure you go take the attendance tomorrow on Canvas and do the review that I post on WebAssign, okay? Yes.
It's all for Friday?
How did I get the r root equal to square root of 2? We're good? Okay. All right, guys, those of you at home, you're good to go. Those of us in the classroom, let's wipe down our desks. We've got the spray right over there.
So that's all we need to do for Friday? Just the attendance and the review?
The attendance and the review, yes, for tomorrow.
Right, thank you so much. Have a good day.
You too. Yeah, you don't have to turn it in tomorrow, but you need to have all the ones that you know how to do done on that review, so I can just answer some questions on Monday. Do I take attendance? Yes. For Fridays? So you get onto Canvas, and there's a Friday section on Canvas, and it'll say attendance. You just type your name in and you submit it. It has to be done by 3:30, but that's your attendance showing that you're there.